I'm Jackie and she's Carol, and we are talking about our final project, reinforcement learning. Because in the midterm, we want to solve some problem that in our document, like we want it to work in varied environment and we want to cut down the noise. So we think about using reinforcement learning to realize our motivation. And there are two problems that we want to solve. And one is we want to, because every time we work on the document, we need to adjust the parameter, and we want that every document we can use the same parameter and work well. So it's our motivation. And another problem is that some noise like white line or some background noise will disrupt the lens filter. So we want to cut down the noise. So let's talk about reinforcement learning. Reinforcement learning is a try to learn case. So it's like this picture. We have, this one is agent state, and we have our environment. And there are some actions and we have rewards, and if we have some positive reward and negative reward, and finally we want to choose the best option. And there are some policy of transition from state to action and some rules that we observe from agent observers. This is our technical realization. We have some steps to realize our project. At first, we have the camera catch the picture like this one, and this will find some segment like white line and yellow line, and we want to transfer it to Q matrix so we can do Q learning. Transfer from the line segment and we transfer to like matrix like this one. And we use Q matrix to do Q learning. So we use the matrix like last page and doing this learning. So we have action, we have environment, and we do some rewards, observation, so we can get the optimal option we want. So we have three actions like moving forward and turn left, turn right, and by these three actions, we let the document run in this environment, and it will avoid the noise and find the best path to let the document to work. So reinforcement learning have rules that determine the skill immediately reward of a transition. So we can get the reward if like this one. After we learning, we can find the path that we can get it back to lens filter. So document can work like moving in the middle of the road. After we find the direction of the path, we get it back to lens filter, and this new segment will replace the white line and yellow line. So we'll follow the red line. And we do some simulation. This is using MATLAB, and in the left side is the environment we built, and we try to like window that can move. So in the right side we use Q learning and we find a path, and it has the step 1, 2, 3, 4, 5 to 12. So it can get a goal, and when it reaches this goal, we have moved on to next window. And it do the same step, so the document can work in this same learning and find the way.
Jackie introduced about in the MATLAB we try. And now I want to show you that in Spider, in Python environment that we do. Because in the car, our segment meets some mistake that the segment missing. So this package is I try to imitate the segments that the line detector pass to the line filter. And as you can see, first it will show this map, and this map about the border and the path, like the zero region. And then the computer will try every step that can it do. So you will see at first it randomly action, so the step will very large, and then it will reduce to the small path. And it is the result of our path. It will become from there to the goal of in our picture. And we translate those vectors into the new segments and use this new segment to the length filter. Thank you, everyone.